Hello everyone, Electrical Engineering Department of ASMSCO Pune welcomes you. Today I am going to present you measurement of dielectric constant and loss factor, which is prepared by Sakshi, Prajakta and Kavita under the guidance of Professor M.H. Thenman. In this video, we are going to see dielectric constant, loss factor, Schering bridge, and a numerical related to it. So, what is dielectric constant? It is simply the relative permittivity of the insulating material. Or we can say that it is the ratio of the charge stored in an insulating material placed between two metallic plates to charge that can be stored when the insulating material is replaced by vacuum or air. Or simply we can say that it is the ratio of permittivity of the substance to the permittivity of the air or vacuum. As it is the ratio of the permittivity, so it has no units. The characteristics of dielectric material are determined by the dielectric constant. Many of these insulating materials have dielectric constant more than unity. This material shows a dielectric loss when subjected to the AC voltages. Then what is the dielectric loss? So it is the loss appearing in the form of heat due to the reversal of electric stresses compelling molecular rearrangement known as the dielectric loss. Dielectric constant as well as dielectric loss. Both are depends on magnitude of voltage stress and the frequency of the applied voltage. Dielectrics are generally used in capacitors or cables. Variation of and dielectric loss with the frequency is very important in such equipments. Generally, variation of these two quantities with respect to the frequency is combined together to be known as the complex quantity or complex permittivity. The value of this is to be determined at different values of the frequency. Now, through this phasor diagram, we can find out the loss angle. So, in the ideal case, that is in the loss-free capacitor, IC is leads the voltage VC by exactly 90 degree. But in actual case, that is in lossy capacitor, the lead angle is forced by some angle del. This angle del is known as the loss angle. The current leads the voltage by less than 90 degree, that is theta. So theta is equal to 90 minus del. IC and IR both are the components of the current, whereas IR is given by IR, which is charging current, which is given by the voltage upon resistance of the dielectric, and this impedance triangle is find out from this phasor diagram. So now Schering bridge. There are various methods for the measurement of capacitance and dielectric loss. Schering bridge method is a very important and popular method to find these terms. That is measurement of the capacitance and dielectric loss. In this method, the imperfect capacitor can be compared with the perfect capacitor. That is C2 is compared with the C1. The imperfect capacitor is represented by its equivalent loss-free capacitor C2 in series with the resistance R, which is shown by the following figure. So, earthing as shown is to safeguard the operator at high voltage testing. From this diagram we can find out these impedances. So, from this Z1 is equal to minus J upon omega C1. From this C2 in series with the R, we can find out Z2 is equal to R minus J upon omega C2. And similarly, Z3 is equal to R3 and Z4 is equal to the 1 upon 1 upon R4 plus J omega C4. On rearranging, we find the R4 upon 1 plus J omega C4 into R4. Now, for balance as indicated by the detector, we can say that Z1 into Z3 is equal to Z2 into Z4. That is, Z1 into Z3 is equal to Z2 into Z4. So from solving this Z1 into Z3, we get this minus J into R3 upon omega C1. And solving Z2 into Z4, we have R minus J omega C2 into R4 upon 1 plus J omega C4 into R4. On solving this equation, we get minus J R3 upon omega C1 into 1 plus omega C4 into R4, which is equal to R4 into R minus J omega C2. Separating the real and imaginary part from this equation, we get the C2 is equal to C1 into R4 upon R3 and R is equal to R3 into C4 upon C1. So, we have tan del. Now from this we have tan del. Del is our loss angle. So tangent of loss angle is given by R upon XC, which is equal to R upon 1. In this, XC is 1 upon omega C2, which is from very basic of our electrical. So it is equals to omega into RC2. Now we can solve this example. A shearing bridge, when used to measure the capacitance and loss angle of the bushings, following observations are obtained. Standard condenser is equal to 200 pf picofarad. Then R3 is 4000 ohms. C3 is 0.00125 microfarad, and R4 is equal to 500 ohms. Now the question is, what are the values of the capacitance and the loss factor? So from this derivation, we have the value of capacitance and the loss factor. So we can solve this question. So the given things are C1 is 200 picofarad and C3 is 0.00125 microfarad. R3 is 4000 ohm and R4 is 500 ohm. So from the equation C1 into R4 upon R3, we can find out the C2, which is in this C1 is 200 into 10 raised to minus 12, as the given value is in picofarad, so we multiply it by the 10 raised to minus 12 into R4 and R3, that is 500 and 400. So the obtained C2 is 25 picofarad, and R is equal to R3 into C4 upon C1. On solving this, we get the loss factor. These are some good video links related to our topic. So, any questions? So, if you have any doubt or query related to our topic, please comment below. We definitely try to answer your questions. And now, at the end of our video, I can only say that please do like, share, subscribe to our channel. Thank you.